Hello friends. In last session, we have seen some of the applications of partial derivative such as maximum minimum and maximum minimum with respect to the constraint. And then we have seen the tangent plane and normal line and the Jacobians. Now in today's session, we are going to start with gradient and the directional derivatives. So we are going to first check out what is the gradient, and then we are going to check out what is the directional derivative. So the gradient of a three variable scalar function capital F of x comma y comma z is denoted by grad f or nibla f and is defined as grad f is equal to nibla f is equal to I into del f by del x plus j into del f by del y plus k into del f by del z. Now grad f denotes the vector function as I, j and k are unit direction vector of x-axis, y-axis and z-axis, correct? So this will give you the vector quantity. So f is a scalar function and grad f is a vector function. Now basically gradient gives you the slope, okay, of a tangent and it is the directional. Same manner, if to find the gradient of a curve in a two direction, you first have to draw the accurate sketch of a curve and at a point where you need to find the gradient and then draw the tangent to the curve at that point by joining that. So a tangent to the curve or a straight line which touches the curve at one point only, correct? Tangent is always going to be touch your curve at only single point. Then you can find the gradient of this tangent. Then the gradient of this tangent is nothing but it is the slope of a tangent. So we are starting with an example. Find the gradient of a tangent curve y is equal to x square at the point 3, 9. Now see y is equal to x square is a parabola along y-axis, positive y-axis, and the point is 3, 9 which is satisfying your parabola. Now first of all, we have drawn one tangent at a point 3, 9. Now the gradient of a tangent, if you have to find the gradient, then we are going to take one another point lies on a curve. So we have taken the another point 2.3, 5. Now if you have to find the tangent, then you have to apply the slope formula. So if you are finding the slope of a tangent, then it is nothing but change in y divided by change in x. So change in y, that means 9 minus 5 divided by change in x, that means 3 minus 2.3. So that means 4 upon 0.7, that is approximately 5.71. Now see, this is not the exact value of a slope. As this point is tending to your original point 3, 9, then this value is going to be more accurate. And if you are going to apply the simple method to find the tangent, then the perfect answer of a tangent is nothing but it is a 6. Okay. Now we are defining the parallel lines. Two lines are parallel if they have a same gradient. That means if both have a same gradient value, then they are said to be a parallel line. Here we have drawn two parallel lines. Y is equal to 2x plus 1 and y is equal to 2x plus 3. Here see, if you are finding the tangent, gradient of a tangent, then it will be a 2. So, and it is going to be same for both of them. So, they are going to be a parallel line. Now, perpendicular lines. Two lines are perpendicular if one is a right angle to the another. Okay, that means if two lines are intersecting each other at a 90 degree, then we are going to say that two lines are perpendicular. If two lines are perpendicular, then their gradients we multiply together will give you the answer -1. Here in a figure we have taken the two lines, y is equal to 2 minus 5x and second one is y is equal to 1 by 5 into x. So if you are going to multiply the tangent of both of them, then that will be a -1. Okay. So the angle between these two lines are going to be a -1. Same manner, now we are going on to the example with a simple gradient function. Find grade f or a nebula f at a point 1, comma -2, comma 1 if f of x, y, z is equal to 3x square y minus y cube z square. Okay. So first of all, your function is 3x square y minus y cube z square. So for gradient, first we have to find out del f by del x, del f by del y, and del f by del z. That means del f by del x, that is fx, is nothing but derivative with respect to x, that is 6xy. Same manner, derivative with respect to y, that will be a 3x square minus 3y square into z square. And if you are differentiating with respect to z, then the derivative is going to be a 2y cube z. Okay. Now, using the definition of gradient, so grade f has a value I into del f by del x plus j into del f by del y plus k into del f by del z. That means it is I into 6xy plus j into 3x square minus 3y square into z square plus k into minus 2y cube z. Okay. So these are three values and you have to find the gradient at a point 1, -2, 1. So we are going to put the values of x is equal to 1, y is equal to -2 and z is equal to 1. So if you are going to put x is 1, y is -2 and z 1, then your gradient is going to be a I into 6 into 1 into -2 plus j into 3 into 1 square minus 3 into -2 square into 1 square plus k into -2 into -2 cube into 1. So if you are simplifying it, then you will have I into -12 plus j into 3 minus 12 plus k into 16. And after simple simplification of it, you will have grade f at a point P is -12i minus 9j plus 16k. Now, we are going on to one another example. Prove that grade of r raised to n is n into r raised to n minus 2 into r bar, where r bar is nothing but xi plus yj plus zk and r is nothing but mode of r bar. That means r bar is your standard position vector xi plus yj plus zk and simple r is nothing but mode of r bar, that is modulus value of the position vector is a simple r. So here r bar is equal to xi plus yj plus zk and if you are going to find mode r bar, then r square will be r square will be x square plus y square plus z square because it is a mode value. So under root and square will be cancelled out and you will have x square plus y square plus z square. Now differentiate both sides with respect to x. That will give you 2r del r by del x is equal to 2x. 2 will be cancelled out and that will give you del r by del x is equal to x upon r. Same manner del r upon del y will be a y upon r and del r upon del z will be a z upon r. Now we are starting with a definition of a gradient. So grade of r raised to n is nothing but I into del by del x plus j into del by del y plus k into del by del z of r raised to n. That means I into del by del x of r raised to n plus j into del by del y of r raised to n plus k into del by del z of r raised to n. Now, if you are differentiating r raised to n with respect to x, then the derivative will be n into r raised to n minus 1 into del r by del x. Same manner, derivative with respect to y will be n into r raised to n minus 1 into del r upon del y. Same manner, derivative with respect to z is n into r raised to n minus 1 into del r upon del z. Now substitute the value of del r by del x, del r by del y and del r by del z. So del r by del x is x upon r, del r by del y is y upon r and del r upon del z is z upon r. So that will give you the final simplified term grade of r raised to n is equal to I into n r raised to n into x into r raised to n minus 2 plus j into n into y into r raised to n minus 2 plus k into n into r raised to n minus 2 into y. Sorry, z. So n into r raised to n minus 2 common out, and you will have n into r raised to n minus 2 into xi plus yj plus zk. But xi plus yj plus zk is nothing but it is our position vector r bar. So that will give you gradient of r raised to n, that is n r raised to n minus 1, sorry, n minus 2 into r bar. Okay. Now we are going on to one another example. Find the angle between the surfaces x square plus y square plus z square is equal to 9 and x square plus y square minus z is equal to 3 at a point 2 minus 1 2. Now see, if you have to find the angle between any surfaces, then we are simply using the formula of cos theta. Now P point is given, we are going to name it capital P is equal to 2 minus 1 2 and name two surfaces by phi 1 and phi 2. So phi 1 is equal to x square plus y square plus z square minus 9 and phi 2 is equal to x square plus y square minus z minus 3. Okay. So first we are going to find grade phi 1. So grade phi 1 is a gradient vector that is given by I into del phi 1 by del x plus j into del phi by 1 by del y and k into del phi 1 by del z. Now derivative with respect to x of phi 1 is 2x. Derivative with respect to y of phi 1 is 2y and with respect to z is 2z. So you will have 2xi plus 2yj plus 2zk. And if you are going to substitute the point 2 minus 1 2, then we have grade of phi 1 at a point capital P is 4i minus 2j plus 4k. Okay. Now we are going to find grade of phi 2. So grade of phi 2 is I into del phi by phi 2 by del x plus j into del phi 2 by del y plus k into del phi 2 by del z. Now derivative of phi 2 with respect to x is 2x, with respect to y is 2y and with respect to z is minus 1. So you will have 2xi plus 2yj minus k, and if you are going to substitute the point capital P, that is 2 minus 1 2, then you will have answer grade phi 2 at a point P is 4i minus 2j minus k. Now if you have to find the angle between two surfaces, then you have to find out the angle between two gradient vectors at a point, that is both are going to be same. That's why we are starting with a cos theta is equal to grade phi 1 dot grade phi 2 divided by mod grade phi 1 into mod grade phi 2. So grade phi 1 has a value 4i minus 2j plus 4k and grade phi 2 has a value 4i minus 2j minus k divided by mod of grade phi 1, that is nothing but under root of 4 square plus minus 2 square plus 4 square, and same manner grade mod of grade phi 2, that is under root of 4 square plus minus 2 square plus minus 1 square. So in denominator, first term will be a 16 plus 4 plus 16, that is under root of 36, that has a value 6. And second bracket has a under root of 16 plus 4 plus 1, that is under root of 21. And in numerator, you are going to take a dot product. So I component is multiplied, J component is multiplied, and K component is multiplied. And that will give you 4 into 4 plus minus 2 into minus 2 plus 4 into minus 1. So 16 plus 4 minus 4, and that will give you 16 plus 4 minus 4, that will give you 16 divided by 6 root 21. The 2 will be cancelled out and the answer will be 8 upon 3 root 21. So that will give you theta is equal to cos inverse 8 upon 3 root 21. This is the angle between two surfaces. Now we are going on to the directional derivative. The rate of change of a function of a several variable in the direction of coordinate axis is known as a directional derivative. The directional derivative of any function f of x, y, z in the direction of a vector a cap, that means we are taking the unit vector in which we are finding the directional derivative, is a component of grade f in the direction of a cap. The directional derivative of f in the direction of a bar is given by capital D A of f, or you can define it in a form of grade f dot a cap, where grade f is nothing but your gradient of a function and a cap is a unit vector in which you are finding the directional derivative. Okay. Now we are going on to the example. Find the directional derivative of f is equal to xy square plus yz square at a point 2, minus 1, 1 in the direction of a vector I plus 2j plus 2k. So here f is nothing but it is xy square plus yz square. So grade f is going to be a I into del f by del x plus j into del f by del y plus k into del f by del z. Now del f by del x that has a value y square. Same manner del f by del y that has a value 2xy plus z square. And del f by del z has a value 2yz. So your grade f is I into y square plus j into 2xy plus z square plus k into 2yz. So we are going to put the point 2 minus 1 1 and that will give you grade f at a point is I plus j into minus 4 plus 1 plus k into minus 2. That will give you the answer I minus 3j minus 2k. So this is your grade f. Now the direction vector is I plus 2j plus 2k. So a bar is I plus 2j plus 2k, and therefore if you are finding the a cap, then it is a bar upon mod a bar. So the directional derivative capital dA of f is equal to grade f dot a cap, that is grade f dot a bar upon mod a bar. Now grade f has a value I minus 3j minus 2k and a bar is I plus 2j plus 2k divided by mod of a bar, that is under root of 1 square plus 2 square plus 2 square, that is 1 plus 4 plus 4, and that will be a 9. So root of 9 will be 3. So denominator has a value 3. Now taking the dot product of numerator, that will be give you the I component, JJ component and KK component. So that will give you 1 into 1, minus 3 into 2 and minus 2 into 2. And addition of these 3, that means 1, minus 6, minus 4. That will be a minus 9 upon 3. That will have a value minus 3. So this is a directional derivative of a given function in a given direction. Okay. So these are the topics which we have covered today. If you have any query or any doubt regarding this topic, then please feel free to contact me. Thank you.